Hello and welcome to another video. In this video we're going to be working on daily temperatures, and it's definitely a solid interview problem that you should know how to do. It's not super hard and it has fundamental algorithms. So in this problem you're given an array integers temperatures represents the daily temperatures. Return an array answer such that answer I is the number of days that you have to wait after the ith day to get a warmer temperature. If there's no future day for this, keep it 0. So we're going to go through example 1 and kind of exactly what they're talking about and how to get these things. So here we have our days. So basically, for each day, we have to see what's the day that is the closest day to this that has a higher temperature. So for 73, it's going to be this day over here. So how many days is that difference? That's 1 day difference, so we're going to mark this. Now for 74, what's the closest day that's bigger than it? 75, so that's 1. For 75, there is 76, so that's 1, 2, 3, 4. For 71, that's 72, 2 days apart. For 69, 72, 1 day apart. 72, 76, 1 day apart. 76, there's nothing bigger, so we're going to leave this as 0, and there's nothing after 73. So it should be 1142, 1100, and here it is right here. So that's kind of what we're looking for. So essentially for every day, we want to know like what's the closest day. So let's think about how we'd want to do this. Like what's the minimum amount of information we need to store? Well, let's say we have, let's say we just store the current day or something. Let's say we have a temperature at 73 at index 0. And we get to the next day. So as soon as we get to the next day and that day is bigger, we don't need to store this anymore because we kind of found the bigger day than this, right? We just said like, oh look, 74 is bigger than 73. So therefore, we don't need this anymore. We can just figure out the distance there and record it. So we can get rid of that one. Now let's say for 74, we store 74 with an index 1 and we get to 75. So for 75, kind of the same thing, right? We found 75 is bigger than 74. We don't need 74 anymore. We're only checking days to the right of the current day. So then we'll store maybe 75 with an index of 2. And then we have 71. So 71 is smaller than 75. So that means we need to keep both 75 and 71 because we're looking for a day that's bigger than both of those. So 71 we'd also need to keep. Then we get to 69 and 69 we'd also get to keep, and so on and so on and so on. So that's kind of the idea, is you're going to be storing your temperatures in decreasing order, and then anytime you find a day that's bigger, it's going to get rid of a bunch of stuff. So let's say we have our temperatures in decreasing order, like let's just say we have some random numbers. We have like 75, 71, 69, and we're going to be storing the temperature and the index, so then we know like how many days is apart. And let's say we get to some temperature that's bigger than 69, let's say we get to like 72, then we're gonna be crossing stuff off from the right. Because our temperatures are in decreasing order, we can just go one by one and see like, is our current number bigger than this? Is it bigger than this? Is it bigger than this? And because the rightmost one will be the smallest, you'll be able to do this efficiently, right? You won't have to see like where is the smallest element. So for 72, we'll say it's big in 69, so we don't need 69 anymore. We found the bigger element. We don't need this element anymore either, and then we'll just plop on 72. And so this data structure is called, and these are ones that you should be aware of, it's called a monotonic decreasing stack. And basically, in layman's terms, what that means is just you have a stack of elements that are decreasing or equal to each other. I don't remember if a monotonic decreasing can have elements that are equal, but either way, like every element will be less than every other element. So it'll be decreasing. And the other one you can have is a monotonic increasing stack, and whenever you use a stack data structure, those are like, for the most part, that's what you're going to use the data structure for. It'll either be monotonic increasing or decreasing, and that will give you the biggest or smallest element in of one time because it'll just be the last element. So let's walk through this again with our stack, and let's walk through like exactly what this is going to look like. And this works for any problem that you want to find like the next greater element or the next smaller element or something. You would want to use a monotonic increasing or decreasing stack. So let's actually have we do have a stack, looks like. Hopefully we have enough space here. So let's use a stack. So essentially, like I said, we are going to be storing the element and its index. So for 73, we're going to first check, is anything in our stack? No, it's not. So we're just going to store 73 with its index. So we'll store 0 and 73. Then for 74, we're going to check, is anything in the stack? Yes, it is. Is 74 bigger than the number in the stack? Yes, it is. And how many days apart are those? They're 1 day apart. So that means for whatever is in here, we're going to take this index and put a 1 in this index. And then we are going to record the 74 along with its index. So 74 with an index of 1. Now we will go to our next element, so 75. Is 75 bigger than the top of our stack? Yes, it is. So we will get rid of this element. And this had an index of 1. That means we are at currently 75, so we can mark that. We're at 75. We had index of 1. Now we have index of 2, so those are 1 day apart. So for whatever was that index of 1, this is 1 day later, so this is 1. Now we will store 75 with an index of 2. So 2, 75. Then we will move on over here. So is 71 bigger than the top of our stack? No, it's not. So that means we will store the value and its index, 3. And now we get to 69. So is 69 bigger than the top of our stack? No, it's not. So we will store it. So this is 4, 69. Now we get to 72. Is 72 bigger than the top of our stack? Yes, it is. So 72 is bigger than 69. It is an index of 5. 69 had an index of 4, so that's 1 day apart. So for 4, we will write 1 and get rid of that element. Then is 72 bigger than 71? Yes, it is. It had a day of 3, so these are 2 days apart. So for index 3, we will write 2. And finally, is it bigger than 75? No, it's not. So we'll just add on the 72 now with an index of 5. So whenever you're done getting rid of elements, you will just always push on the item onto the stack. And so, yeah. So next, we are going to go to 76. And 76, is it bigger than 72? Yes, it is. So for 72, is that index 5? This is that index 6, so one index difference. So we're going to put a 1 here, get rid of 72. Then, is 76 bigger than 75? Yes, it is. The difference is 4 days. So here we will write 4. And finally, we will put on 76 into our stack. So 76, let's actually just delete it, with an index of 6. Then we'll go to our next item. Is 73 bigger than 76? No. So we'll just put on 73 with an index of 7. And we can just initialize every single element in our result array to be 0. So whatever we didn't fill in will just be 0. So now if we look, it's 1, 1, 4, 2, 1, 1, which is the same thing. So that's kind of how you do it. You just have a stack, and because you're looking for the next greatest temperature, your stack is always going to be decreasing, and then every temperature will just automatically find the smallest available one in the stack. And if it's not smaller than the smallest available one, or it's not bigger than the smallest available one in the stack, then it's not bigger than the rest of the stack. So we don't need to check our whole stack. We can just check efficiently just the last element. And yeah, that's going to be all for this one. So let's code it up now. So we're going to have a result array. We'll just initialize everything to 0. Maybe you can even rename this to like temps or something just to make it shorter. Then we're going to have a stack. And now we want to go through every single index and the temperature in our temperatures. So for index and temp and enumerate temps. Now, remember, what we need to do is we need to check while we have a stack, and while our current element is bigger than the top of the stack, we need to be popping off elements. So while stack and temp is greater than stack. And the way we're going to store our stack is, like I said, we're going to store a tuple of index value. So it's going to be the top of our stack and the second element in there. So you can do this as well if this makes more sense to you. So the top of our stack and the second element in there will be the actual value. So we will pop off those things. So all we really need, we don't really care about the value anymore. We know that our current element is bigger. We just need the index. So we can just say like location, and this we're not going to use, equals stack.pop. And we need to figure out this difference, right? So result at index location is the index of the element equals the current index minus that location. That's how many days have passed. Finally, once we're done popping things off the stack, we will append. So we will append a tuple of the index and the temperature. And then we will return result, and whatever's left on our stack, it doesn't really matter because those will all be 0. Like the trick for these kinds of problems, or not the trick, but if you want to return some value and you want to have a default value, just initialize the whole array to that value. And then if you never change it, it'll just be that value to begin with. So if you wanted to return -1, for every value that wasn't found, just initialize this to -1. And if we can run it. Oh, we need a tuple here. Okay. And there we go. So pretty good. So this is going to be, yeah, and like I said, this is probably, if I had to guess, it's probably a common interview problem. Let's take a look. Yeah. because it's pretty easy and it tests basic algorithm knowledge. So this is going to be time O of n. So most stack things are going to be O of n, because you will at most put an item on the stack once and pop it off the stack once. And the space is O of n for our stack. Yeah, so that's going to be all for this one. Hopefully you like this one. Definitely one that you should be knowing. Not a hard problem at all. Let me know what you think. Write in the comments and so on. And if you did like this video and this explanation, as always, please like the video and subscribe to the channel. I think we're getting close to like 900 subs, so hopefully get to 1,000 pretty soon. That'll be great. Okay, and thanks for watching.